Hi, my name is Boston Williams, and I'm going to be presenting Simpson's paradox. So I'm in probabilities and statistics, Math 32. My lecture is number 20. My discussion is number 24, and this is the spring semester of 2021. So here we go. And so, what is Simpson's paradox in a nutshell? Basically, it's a phenomenon in which trend or themes occur in several groups, but disappears when you put all those groups together. You can see this to the right. The different colors basically mean the different data sets that was given to you, and you see that the trend is usually a line going from the top left to the bottom right. However, when you put those data sets together all in one graph, you realize that the overall trend is a line in the complete opposite way from the bottom left to the top right. And so I'll explain a little bit later on the meaning of this kind of. And so usually this occurs in social science and medical science statistics, and it's problematic when data is given casual interpretations leading to wrong assumptions. And basically that kind of means if you only look at data through a microscope, only in small data sets, you're going to gain trends or observations that you're going to see, and you're going to think those are strong, hardcore facts. But if you look at the overall picture, and I'll give examples of this, you realize a whole new different trend occurs, and maybe some trends or some theories that you had in the past just looking at a small data set could be falsified by this new observation. And so a mathematical observation of this is if you have Sophia and Carlos, right, and they both made a song, and you told people to rate which song was better. The overall trend is that Carlos' song is better. I mean, if you look at the male percentages and the female percentages, you realize that Carlos has a better percentage in both those categories, 50% for the male, 90% for the female, compared to Sophia's 30% and 80% respectively. However, if you combine the two, you realize, oh wait, Sophia has a better acceptance record of 62.5 compared to Carlos's 45%. Why is this? And so this is, you can easily see if you look at both Sophia and Carlos's recommended, let's say likes, right? And you add them up because they both were out of 400. So 400 people rated both songs. You realize, oh wait, 250 people said yes out of 400 for Sophia, and only 216 said yes out of 400 for Carlos. So if you only looked at this through a microscope, you would realize, okay, Carlos might be the winner, but overall, you realize Sophia actually has the better song through the mass of people that voted. And so basically, this is an illusion of a trend. It's simple. So Simpson's paradox can occur in a variety of different situations, from gender bias, medical treatments, or even baseball. I mean, I said this in the past. And this misinterpreted information led by this paradox can lead to many problematic interpretations. A small one was who's the better songwriter, but a more serious one is there gender bias in schools? Are there more male applicants that are accepted than female applicants, or is there race bias or anything like that? That's more of a serious topic. And so, like I said before, like I said in this thing, you can problematic interpretations about better baseball players, better forms of treatment, even the amount of gender bias in schools. And to prevent this, it's important to look at each subcategory individually and combined in order to be aware of the whole picture of the circumstance. And I really underlined the "and" portion because you can't just look at the overall picture or the small picture. You got to look at both and kind of compare and contrast which one you're going to have more weight on your findings. But you can't just nitpick which way goes more towards your theory than the other. And so this is a good example of it. It's you and your friend go to the hoops to shoot some hoops for 5 consecutive days. And on Wednesday, after the 5 days are up, you notice that your friend has a better shooting percentage all but one day. So on Tuesday, you kind of stepped up your game and you had a better shooting percentage than he did. But you realize that out of the total shots taken, you edge out your friend in total shooting percentage. So who's the better shooter? And like I said, you can either say that your friend's the better shooter because on the day-to-day basis he had a better percentage, or you can say you're the better shooter. And with some simple math, you realize that you've made 29 out of your 40 shots compared to your friend who only made 28 out of his 40 shots, meaning you're the better overall shooter out of the competition. So world beyond. And so this is basically explaining where you can find this in everyday life. And so Simpson's paradox can be found in a multitude of different situations, ranging from a friendly game like I just explained, a basketball, to the efficiencies of medical treatments for diseases. And that's for cancer or small cell lung cancer or something like that. But by only looking at statistics through a microscope, Many observations can be made or trends are observed. However, you can when you take the microscope away and you look at the bigger picture, maybe some of those trends are falsified, new conclusions are made. And so it just depends on the willingness to compare both the small trends observed under the microscope by looking at each subsection individually, or the bigger picture if you just put them all together and see overall which one's better. Can a strong statistical data can be that can be applied in the real world can be attained. And so basically, it's just look at both and find your findings that way instead of just looking at one. And so these are my references that I've chosen. I've used the book and then 2 online resources to get really good background information on this topic. But thank you for listening to me, and have a good one.